Trying to predict the future, it's one of our oldest obsessions as humans, right? From guessing tomorrow's weather to forecasting the stock market, we're always trying to figure out what's around the corner. For decades, we've leaned on statistics and data to build our crystal balls. But now, a totally new kind of intelligence is showing up, and honestly, it's changing the entire game. Okay, let's get into it.
So how do we actually do it? How do you take a string of numbers from the past, I'm talking monthly sales figures, daily temperatures, you name it, and project them out into the future? Well, that whole process is called time series forecasting, and it's the big question we're going to unpack today.
And believe me, this isn't just some academic thought experiment. This is a super high-stakes field with massive real-world consequences. We're talking about retailers trying to predict demand for thousands of products, financial analysts modeling market movements, even healthcare pros trying to forecast disease outbreaks. Getting it right can save millions. Getting it wrong? Well, that can be a disaster. So here's our roadmap. We'll start by looking at how we predict with data. Then we'll pit two very different models against each other, a classic and a new challenger. After that, we'll see why machine learning models are the current champs when it comes to accuracy. Then we'll dive into what makes LLMs the real rule breakers, how they can forecast with context, and finally, what the new AI toolbox for forecasters really looks like. All right, let's kick things off with a head-to-head competition. In one corner, we have the seasoned champion of statistical forecasting, and in the other, a completely new kind of contender, one that doesn't even really think in numbers.
So, on the left, you've got ARIMA. This is a classic statistical model, a real workhorse that's been used in forecasting for decades. It crunches past data points to find patterns like trends and seasonality. It's pure old-school mathematics. But on the right, we have LLMTIM, which is built on a large language model. And here's the wild part. LLMTIM doesn't really see numbers. It takes a number like 789 and breaks it into individual digits, 7, 8, 9, and then it treats the whole data series like a sentence that it just needs to finish. It is literally reading the past to write the future.
I mean, what a completely different way of thinking about the problem. So the obvious question is, which one is better? The new AI hotness to just blow the old statistical model out of the water, right?
Well, the data actually tells a much more interesting story. This table shows something called mean squared error for both models. Just think of it as a score for how wrong a prediction is, so lower is always better. And look at this. For the classic air passengers and monthly milk datasets, the old-school ARIMA model wins, and honestly, it's not even close. But for Australian beer production and hospital data, the LLM comes out on top. So the big takeaway here is that the new tech doesn't just automatically win, it really depends on the job.
And this brings us to a super important point. If we're talking about pure, raw accuracy on a massive scale, neither of these two models are actually the current king of the hill. Nope, that title belongs to a completely different class of algorithms.
To get a sense of the scale of modern forecasting, just look at this number. Over 42,000. That's how many unique time series were in a competition Walmart ran to predict sales of its products. We're talking about a forecast for every single item in every single store. This is the big leagues.
And who won this massive competition? It wasn't ARIMA, and it wasn't an LLM. The top solutions were all based on powerful machine learning models like LightGBM and XGBoost. These are what are known as gradient boosting algorithms, and they are absolute powerhouses, built specifically to handle huge amounts of data with incredible accuracy. For raw predictive power at scale, they are the reigning champs, period.
Okay, so this gets us to the real heart of the issue. If LLMs aren't always winning the accuracy race, then what is all the excitement about? Well, it's because their true value isn't about playing the old game better, it's about changing the rules of the game itself.
So let's look at their first unique skill, anomaly detection. Now, this isn't about predicting the next number in the sequence. This is about looking at a whole series of data and spotting the one thing that just looks weird. Identifying that unexpected spike or that strange pattern that could signal a system failure, a fraudulent transaction, or a sudden market shift.
And these anomalies can be incredibly subtle. It might be a single odd data point or a whole section of data with a funky seasonal pattern. Or if you have data with multiple variables, maybe one whole variable starts acting strange compared to all the others. Because LLMs are so good at understanding context and sequence, just like in a sentence, researchers are now exploring how they can be used to spot these complex, nuanced patterns that other models might just miss.
But here it is. This is the biggest game changer, the thing that really sets LLMs apart. It's their ability to understand not just numbers, but language. And this opens the door to something called multimodal forecasting, basically baking real-world context directly into the prediction itself.
This slide just illustrates the shift perfectly. We are moving from a world where we only look at the chart of numbers on the left to a world where we can combine that chart with the news report on the right. I mean, think about it. If you're trying to predict a company's stock price, wouldn't you want to feed the model not just the historical price data, but also the company's latest earnings report or news about a new product launch? Of course you would.
And this is exactly what a brand new framework called TimeXL is designed to do. It's a system built specifically to fuse that numerical time series data with all kinds of text, using a whole team of collaborating large language models.
What's so clever about this whole process is that it's a closed loop. First, a model makes a prediction using both the numbers and the text. Then, a second LLM acts like a critic. It looks at the prediction, compares it to what actually happened, and figures out if the text was maybe misleading or just noisy. Finally, a third LLM takes that feedback and actually refines the text to make it better for next time. And the whole system retrains. It's a system that doesn't just predict. It learns, it critiques itself, and it improves.
And does it work? Oh yeah, absolutely. Research shows that by adding this layer of text and LLM-driven reasoning, the TimeXL framework can improve prediction accuracy by almost 9%. That is a huge boost, and it just proves that context is king.
So, where does all this leave us? Well, it seems like the world of forecasting is becoming less about finding one single best model and way more about building a toolbox with the right tool for the right job.
Think of it like this. ARIMA is your trusty hammer. It's simple, it's reliable, and it's perfect for straightforward jobs. XGBoost and LightGBM, those are your high-powered drills. When you need to get through the toughest material with maximum accuracy at a massive scale, they are unbeatable. And LLMs, they're the new intelligent multi-tool. It might not always be the most powerful drill, but it can do things the others just can't. It spots anomalies, it brings in context, and maybe most importantly, it can start to explain why it's making a certain prediction.
And that right there, that really gets to the heart of it. The whole paradigm is shifting. We're moving away from just chasing another decimal point of accuracy and moving towards a future where our models can give us a much deeper understanding of what's really going on. We're moving from asking what to asking why.
And that leads us to our final thought for today. If an AI can give you not just a prediction, but a whole narrative explaining its reasoning, hey, I'm forecasting a drop in sales because of these negative news articles and this worrying trend I see in the supply chain data. How does that change the way we make decisions? What does it mean for us when our crystal balls finally learn how to talk?